Welcome to our YouTube channel Local Techies. I am Sneha Bellala and we will be working together on this journey to learn performance testing, and I will make it as simple as possible for everyone to learn performance testing. In this course, we are going to cover a lot of ground on performance testing concepts and its tools and techniques. And the high level agenda for this course will be basic concepts of performance testing, its tools and techniques, and I will introduce you to one of the most popular performance testing tool, LoadRunner, and later we will see how to script in Vue.jn, which is a component in LoadRunner, how to tweak the scripts and execute it in controller, analyze the scripts. Later we will also look into another load testing tool or a performance testing tool which is open source, that is JMeter. Later we will touch base with performance engineering and its concepts. In today's discussion, we are going to cover what is performance testing, its goals, why we do performance testing, types of performance testing, and performance testing lifecycle. So, now what is performance? Let us take a scenario. Here is a scenario from my typical client for a car manufacturer. There is a point A and another place B, and they both are separated by a distance of 70 kilometers, and my requirement is my car must be able to take two passengers from point A to point B in an hour or 60 minutes, and this requirement is forwarded to my development team, and they have come up with 4 working models and they have given us the models to test. Let us say this is my model 1, this is my model 2, this is my model 3, and this is my model 4. Now, after I do a test on all these models based on my requirement, what I identify is my model 1 covers 70 kilometers in 120 minutes, and model 2 covers 70 kilometers in 90 minutes, and model 3 covers 70 kilometers in 50 minutes, whereas my model 4, it covers 70 kilometers in 45 minutes. Here, all our 4 models are able to take passengers from point A to point B. The intended functionality of my car is successfully met, which means my functional requirement is working properly. But what did we test here is the car designed must be able to carry the number of passengers in a specified amount of time. It should reach the distance A to B in a specified amount of duration. This is called performance testing, and that is what we do. So, in technical terms, performance testing is a technical investigation which is done to determine system parameters in terms of responsiveness, stability, under various workloads. Now, coming on to application performance testing. What do we do in an application performance testing? What do we determine there? We do testing on an application or a system and determine the 3 S. One is speed. It determines how fast the application responds or how fast the application navigates between the pages. Next, scalability. It determines the maximum user load an application can handle. Last is the stability. It determines how stable my application is under varying loads and external conditions also. External conditions play a vital role in performance testing. For example, in our previous examples, we took a car as an example. There, my model 4 was able to cover 70 kilometers in 45 minutes. This results were under a normal road. What if the same car was performance tested in a snow-laden road and the car is attached with a mow? Some of the energy of the car is spent in mowing the snow and the rest is spent on moving the car forward. Obviously, the performance gets affected there. Similarly, external conditions do play a vital role in performance of applications also. Now, what are the goals of the performance testing? The goal of performance testing is to identify and eliminate any bottlenecks that are present in the application. Its goal is not to find defects or bugs in the application. So what is a bottleneck? Bottleneck is a stage in a process that can cause the entire process to slow down or stop. In common terms, a bottleneck is nothing but any reason that can cause the application's performance to degrade. Now, let's move on to why we do the performance test. 1. To actually identify the application response time. How long does the application take to complete a task? Next, to find the reliability. How stable is my system and how reliable is it under a heavy workload? Next, configuration sizing. Which configuration provides the best performance level? Next, capacity planning. What hardware does my application support to provide the intended performance? Next is the acceptance. It is the system to say how stable enough is it to go live or to go into production. Next, the bottleneck identification. Here we identify what causes the degradation in performance of an application. The last is regression. When we deploy a version of a software, consequently we deploy new versions of software which has enhanced features of existing version or new features. So this new version of deployed software should have a better performance but not a lower performance compared to the previous version. That is what we do in a regression performance testing. Next, moving on to what are the different types of performance testing. They are load test, stress test, endurance test, spike test, volume test, and scalability testing. First, let us see a load test. What is a load test? In load test, the application or system under test will be subjected to an anticipated or expected user loads. This helps us to recognize the upper limit of the system and helps us to understand whether the current infrastructure supports our performance requirements and helps us to understand how the load is built and sustained in our system. Now, stress test. In stress test, our system is subjected to unexpected loads of users. This is to determine the application breaking point, and it helps us to identify how our system recovers from a failure and also to check if any unexpected failure harms the system security. Here, the load limit is above the threshold of a break. Now, moving on to endurance test. In endurance test, the system is tested with a load for an extended period of time. This is done to evaluate the system's behavior under sustained use to see if the application is capable to handle extended loads without any performance deterioration. Endurance is conducted for longer periods of time, whereas load test ends in a couple of hours. This is the major difference between a load test and an endurance test. And the primary goal of endurance test is to identify any memory leaks in the application and also to verify if the system performance and response will remain the same or better than the start of the test. Next is the spike test. In spike test, it helps us to determine the recovery time after a spike and helps us to estimate any weakness in an application. It helps us to know how the system responds to any unexpected rise and fall of the load. In spike testing, the system is subjected to large volume of user loads in a very short duration of time. So another goal of this testing is to determine the recovery time between two successive spikes of user load. The system needs some time to stabilize, and this recovery time should be as low as possible. The next type of test is volume test. This type of software testing, the application is subjected to a huge volume of data, and it is done to analyze the system performance by increasing volume of data in database. With help of this, the impact of response time and system behavior can be studied when it exposed to high volumes of data and also helps to identify any data loss in the application and check if data is stored correctly. And also it checks for any data defects and speeds in processing. We can also identify if a system has necessary memory resources, and we can check for logs for warnings and error messages that occurs because of volume problems. And finally, the scalability testing. In scalability testing, we measure the performance of a network or system when number of user requests are scaled up or down. This is to ensure that an application can handle projected increase in user load or traffic or data volume or transaction count. It tests the system, processes, and database ability to meet the growing needs. This testing is done to measure at what point our application stops scaling and identifies the reason behind it. Also, it helps to determine the client-side degradation, end-user experience under load, and server-side robustness or degradation. Now, moving on to performance testing life cycle. Everything has a life cycle. Our project has a life cycle. A software development has a life cycle. Similarly, testing has a life cycle, and even performance testing, which is a subset of testing, also has a life cycle. And the phases in performance testing life cycle are: 1. Requirements phase. Next comes the planning phase, the design phase, execution and analysis phase, and finally the performance tuning phase. Let's see each of them in detail. First comes the requirement phase. In requirement phase, the main objective of this phase is to chalk out the performance requirements in detail and identify the critical business scenarios which need to be monitored. Architecture, both hardware and software of the application, is analyzed with respect to the specific performance requirements for the project. All the critical transactions in the application are gathered and identified for performance testing, along with the user profile and usage pattern. Client feedback and analysis of log of existing application are gathered as key inputs. The above inputs would help in deciding the load patterns that is to be applied on the application and the parameters to be monitored. And the deliverables of this phase would include completed performance questionnaire document, the performance requirements document, and test strategy document. Now, moving on to the next phase, which is planning phase. In planning phase, this involves planning with regard to people, software, including testing and its tool and hardware resources which are required for the project. Necessary connectivity setup to test the regions is established and verified during this phase. Test data and test plan is prepared for requirements collected. A decision on the test environment and the tools to be used and the monitoring parameters on each tier, that is web server, application layer, and database layer, is taken based on the requirement analysis. The necessary approach for carrying out the load, stress, and endurance test or any other performance test is detailed out during this phase, along with the inputs in terms of number of users and number of tests to be run, etc. The deliverables of this phase would include a business process selection document, workflow document, and signed off test plan document. Moving on to our next phase, which is the design phase. In the test design phase, the test environment is verified for its readiness, and after it is verified, the test scripts are recorded and developed for the baselining of test scenarios using the selected load testing tool, and parameter is done for the scripts for varied user sets of data. The results of the test scripts are generated and verified with the business requirements and baselined if the same is found acceptable. The deliverables of this phase would be signed off test scripts, script delivery document, and a dry run test report. The next phase is the execution phase. In the test execution phase, it is carried out in the baseline test environment, either over the internet or at the client location, or even a simulated environment like a performance test lab, which is based on a chosen delivery mechanism. Log setting is done to capture the test sequence of events which are set and observed. The load is generated as per the strategy defined, and the results are captured for various load patterns and the scenarios identified. The deliverables of this phase would be the test session log document and a performance test report. Now, moving on to the final phase, which is the performance analysis and the tuning phase. Here, first, the test results are reviewed and analyzed for any bottleneck in the application by the team of experts for various hardware platforms, operating system, database, and software design. The performance gaps are evaluated and solution approaches for these identified bottlenecks are defined. And we also provide suggestions for tuning the application. Here, the deliverables would include the recommendations to improve the performance and the scalability. This concludes our today's discussion. In tomorrow's discussion, we will see the performance test terminology, the Little's law which is used for performance test workload modeling. Next, we will have a look at the key performance metrics, the performance testing tools available in the market. Then we will have an introduction to our much awaited LoadRunner, and we will also look how to do a LoadRunner installation. Thank you for watching this video. Hope to see you again. Do provide your valuable comments, feedback, or any suggestions in the comment box below. Do subscribe and like and share our channel. Thank you.